This doesn't seem to be on there. The battery died. Oh, hello, hello. Does this work? The volume is very low. Hello, everyone. Do you hear me through the speaker here? All right. You ready to go?
Yeah, I'm just seeing if I can get this guy to work, but if not, it's not a big deal.
All right. All right. Well, welcome everybody for this Halloween-themed Frontiers in Neuroscience seminar. Can you tell I'm a pumpkin? Or at least trying to be one. Anyways, welcome. Today is, we're very delighted to have Deepu Murty here to speak, and he'll be introduced in a moment. But Deepu is being sponsored on this visit through the Center for Mind, Brain, and Culture. And I wanted just to take a couple of minutes to explain a little bit about the center and hopefully encourage anybody who hasn't learned about it before to become one of our affiliates. So the underlying idea, the mission of the center is to support and foster discussion, scholarship, training, and collaboration across diverse disciplines. So we are an interdisciplinary center focused on mind, brain, and culture. The structure is, we're not that hierarchical, but we do have a director who's sitting here, Dietz Stout from anthropology. I'm Robert Liu, the associate director in biology, and we have an advisory committee that spans faculty here in the college across many different departments in the social sciences, the sciences, and even across institutions at Georgia Tech and Spelman. We host a number of different kinds of events and programs, including lectures like what you'll hear today, lunch discussions. We put on symposia and conferences, usually at the end of the year, as well as workshops. You can find podcasts and videos of our past events on our website, where there's an archive. And for this fall, we're now actually almost done with the events that we have planned for the fall. We just actually, earlier this week, had the author and evolutionary biologist David Sloan Wilson here, gave a wonderful talk, and do things like reading groups, where right now we're having a discussion about the book Humankind, A Hopeful History, which is hopefully a positive view on the things that are happening in society today. Some of the workshop conferences and symposia that we put on in the last few years are listed here. And I want to, especially because there are so many graduate students here, point to the certificate program that we offer that gives students a chance for more interdisciplinary training. Here are some of our current certificate program students, including from neuroscience, Caius Ghibli. We also have an undergraduate research fellows program, so we encourage you, if any of you are mentors to undergrads or are an undergrad yourself, to apply usually in the spring, I think around March, to become a research fellow for the next year. And they get to participate in our events and often have sort of back of the room entry to things. And we hope that you will become an affiliate. If you're interested, scan the QR code or just come to our website, cmbc.emory.edu, I think. Yes. All right. With that, I will now turn it over to Kareem, and you guys will do the introduction. All right.
Hello, everyone. I'm Ted Lasso. Good afternoon, everyone. It's my pleasure to introduce today's speaker, Dr. Deepu Murty, who is an associate professor of psychology at the University of Oregon. Dr. Murty earned his Bachelor of Science in Neuroscience from Brown University, followed by a PhD in neurobiology from Duke University, and completed his postdoc fellowship at New York University. Before joining the University of Oregon, He held faculty appointments in the Department of Psychology and Neuroscience at Temple University and in the Department of Psychiatry at the University of Pittsburgh. Dr. Murty's research investigates how motivation and emotion shape memory and decision making, with a particular focus on how affective and motivational states bias what we remember and how those memories guide future choices.
His work has been supported by multiple major funding agencies, including the National Science Foundation, the National Institutes of Health, and the Brain and Behavior Research Foundation. He has also been recognized with Young Investigator Awards from both the Psychonomic Society and the Cognitive Neuroscience Society, reflecting his innovative contributions to understanding neural and computational mechanisms linking emotion and memory. Today, Dr. Murty will present a talk titled Understanding, Remembering, and Communicating Threatening Events. This presentation will explore how threat reshapes the neural architecture of comprehension, altering how experiences are encoded and later communicated. By examining how emotional arousal modulates medial, temporal, lobe, and cortical network dynamics, Dr. Murty's work provides new insight into how threat can distort shared understanding and the social transmission of information, with broad implications for fields ranging from eyewitness testimony to psychotherapy. Please join me in welcoming Dr. Deepu Murty.
Thank you. Do I need to do something, or is it? Okay. Let me change this. Okay, I was like grandiose and way too ambitious when I wrote that abstract. So get ready to be let down, or maybe a lot of that'll have to happen in the discussion section. I should do that more often, whatever I was doing when I wrote that. Oh, does this work? No, I don't need it. Okay. Thanks for inviting me. This is awesome. It was also nice. Like I saw the word society in the invitation. I was like, oh, let me try to think bigger than I normally do. So in a lot of ways, I'm going to present data that's like an arm's reach away from where the core of my research is. But I thought that'd be a fun space to like talk about things, and you can tell me that I'm wrong or tell me how to do it better. Because with the whole communication angle, I'm sort of like stepping into a domain that's pretty new and fresh. Okay. So one other warning, when I get excited, I start to talk really fast. And then the only way to stop me is to ask me a question, and that sets up an event boundary, and then I slow down again, but it's like a ramping scale. So if it ever gets too fast, just somebody like wave me down or insult me or something, and then I can get back to it. Okay. So the whole point of I'm going to try to make today is that like threatening memories are hard to communicate, right? And trying to understand why they're hard to communicate. And I want to start off with an example from my own life that exemplifies this. So I lived in Philly before I moved to Oregon, and there was one night after seeing Everything Everywhere All at Once, which maybe is relevant because it's like a beautiful movie, but also like super violent. So maybe I was in a high arousal state or something. But I was driving home, and then I was at a red light, and back in the day, X used to be called Twitter. And at that time, I was like at the red light on Twitter, scrolling through my phone. And then I heard a bunch of noises and then realized that somebody from the street was like coming up to my car. And then they actually opened my car door and was trying to get in. And they were on like some sort of drugs. And it was like really, really terrifying, right? And I screamed and yelled and ended up having to like slam the gas pedal while the door was open. And it was like a really threatening, traumatic little T trauma event for me. On my way home, I called, and this might be the reason why he's my ex now, but I called my boyfriend at the time, and I was telling him about this because I was like really in a bad way, you know. And then I finally get home 10 minutes later, and when I talked to him, he thought the whole story was that some like friendly person thought I was an Uber driver. And like did not understand that this was like one of the like worst things that had happened to me in the whole year. So to say, like it is hard to express threat and communicate threat to other people. And I'm going to try to unpack a series of older work that I've done and some more new work that's sort of hot off the press to try to understand why it's so difficult to communicate threat. So here's the scaffold we're working with. I think when you're in a threatening event, encoding is going to constrain what representations are available to me when I'm trying to retrieve that event, right? So there's a large literature in emotional memory research with a lot of people in this room sort of founding a lot of this research that talks about those constraints on encoding when you're in threatening situations. Then you can imagine that type of encoding constraints is going to constrain retrieval, and then retrieval is going to constrain our ability of what we can communicate to another individual. So in this way, threat-related distortions in coding can just linger all the way to influence how a naive listener might interpret the way that you're trying to communicate an event. And hopefully I can try to prove this to you today. But the whole idea starts with threat during encoding is going to distort our memories. And you might wonder then, what type of distortions am I talking about? There's hundreds of studies in this space, or maybe tens of studies in this space, but I'm going to pick this one by Ulrika Rimmel that I really like, done in Liz Phelps's lab. And what they did is they had people encoding sort of these really basic images that were either threatening, like a knife, or non-threatening, like a book or something, and they were in a different bordered background, and they were asking people, do you remember this event? And can you actually remember the context in which the event was presented in, right? And when they tested people on their memory, the emotional items that are here in the darker bars, they're remembered better, and people say they really recollect the experience when it's an emotional memory, right? So they're saying like, oh, I can really like place myself back in time and remember it. But the way they set up this experiment is that they could really test it by saying, okay, if you can really recollect when it happened, what was that color border that the picture was associated with? And people sucked at this, right? So despite the fact that they had a subjective experience that they were recollecting and reliving these events the way we think emotional memory works, they were actually worse at this. And this starts to unpack this idea that emotion or threat will basically focus you towards perceptual details or the most salient features in an event, but this is happening at the expense of contextual background information that exists. And there's really nice models of how this is happening. The next two slides are like the only neuroscience I'm going to show you. So tough luck, neuro people, but we can talk about neuroscience at the end. But the idea is that we know there's these pathways that information content will come in through the cortical MTL first, so the perirhinal cortex and perihippocampal cortex, and then that feed forwards information up into the hippocampus, and then you can have binding of these like what and where information together to form sort of a rich episodic memory in the hippocampus. There's some data that I think is pretty strong, but there's some counter examples of this, that engagement of the amygdala in high threat arousing experiences might actually disrupt the flow of information into the hippocampus, also disrupt this sort of cortical feed forward inputs into the hippocampus. So you might be left with these isolated representations of what information or where information, which can then end up sort of giving you these fragmented, decontextualized memories. So a couple examples of this in my own work in graduate school. I can't believe this is over a decade ago. Over a decade ago, when I was in graduate school, we did a really simple experiment. It was actually the cover story of the Milgram experiment. I didn't realize that till I was on my first job interview, and somebody was like, "You ran the Milgram experiment." I was like, "Oops." Okay, but in this experiment, we had people looking at cues of either threat or no threat, and the threat was, if you forget this information tomorrow, we're going to give you a shock. If you remember this information tomorrow, you can avoid the shock. What we found is that people were able to remember the items better in the threat of shock condition versus the no shock condition. We didn't actually give them any shocks the next day. We just wanted to look at this anticipatory threat of shock. But when we looked at, what were the systems that were engaged during this type of encoding, we found that successful memory in the threat condition versus the no threat condition was predicted by amygdala engagement. But moreover, it was having to do with functional coupling of the amygdala with the cortical MTL, right? So we weren't finding any engagement in the hippocampus. We were just finding it in this cortical MTL regions, which we think sort of fosters these isolated representations that are devoid of contextual information. Okay, you don't want to just trust me because, we all like our own work, but this has been shown nicely by a study by Maureen Ritchie, Vichar and Ranganath, where they had people learning threatening and neutral items, and they had contextual information that was embedded to them. When they looked at the effect of emotion, even when people said they were recollecting the experience, right? They have this like really strong subjective sense of confidence. Again, none of this was being associated with hippocampal engagement, but rather we were seeing more engagement of these cortical MTL regions that sort of get more unitized representations when they were actually able to recall the context in which these items were associated with, irrelevant of whether it was emotional or neutral information. That's when you're getting more engagement of the hippocampus, right? So there is this dissociation between these sort of threat biases towards perceptual information that we think involves different neural circuits than sort of these more relational binding things where we can place items in context. Am I making sense? Okay, I didn't feel like I was, but I'll check it. Okay, so again, we think this differentiation of engagement that's happening in coding is going to linger all the way up, making it difficult to actually communicate information to others. But to study this, you have a little bit of a problem. Say I was trying to give you a storytelling event, and this was the memoranda that I'm talking about, right? Like, it's not that hard to convey knife, yellow background, right? Like there's like not a lot of degrees of freedom there to study these types of things we want to study. To study memory communication per se, you need really rich multi-dimensional events that you can actually express in the form of storytelling. So now if I have this picture of a bear with a knife that's attacking a lumberjack in a yellow field of daffodils, now we've got some elements moving that there can be distortions in memory or ways to communicate it more or less efficiently, right? So we have to be in multidimensional experiences if we want to try to tackle this type of problem, which means there's constraints on what you can do in a lab with a bunch of static stimuli, right? We need to get closer to reality if we want to study behaviors that are closer to reality. So let's think about this three-dimensional event and unpack this idea of what I think is happening. Is that in coding, you have this really rich multi-dimensional feature space that has context and time and space and threatening items and intentions and motives and all these other things. But by the time you get to recall, when you're in high threatening context, you might zoom into the source of the threat, remove all the other materials. So you would remember that there was a bear with a knife, but maybe you don't actually remember that the reason the person got attacked is because they're encroaching their personal space in their daffodil field. You're sort of losing all of that context. So then when you communicate it to your dumb boyfriend, they think you were just at the zoo, right? And they're sort of missing the whole three-dimensional space of the picture. So what we wanted to do in these sort of first set of studies is to get people into a really rich, threatening, multidimensional feature space, but we didn't want to lose all of the experimental control you get by capturing what's in encoding. There's been gorgeous work done in autobiographical memory research on recalling threatening events versus neutral events, but we don't actually know what was happening at encoding in all those studies. So it makes it hard to study the veracity of memories in those spaces. But what we were able to do is that I lived like 5 blocks away from this like gorgeous haunted house in Philadelphia called Terror Behind the Walls. And what's nice about a haunted house is that they are doing the same exact thing every night, 6 times a night while people walk through. So now we can get sort of actual evidence of what is going on in the haunted house. So then we can start to test valid memories for this real life event. And it was like really spooky and scary. So these are just a couple stills. There's these really rich rooms with a lot of different perceptual features. There's gunshot noises, there's screams, there's people coming after you with weapons. They weren't allowed to touch you. I went there. This was like my first 2 months in the lab. We launched this experiment. So I was with all my students and they heard like every swear word come out of my mouth. And I was like, good luck being professional, Murty. They've all heard you say the F word like a lot in fear. But it's like a pretty scary event. But we don't want to take my word for it. So just to give you a sense of what we were doing in this study, we had people go to the haunted house. We equipped them with portable heart rate monitors so we could track physiological arousal in the moment. Then they came back 1 week later to the scanner, and then they did free recall for their experiences at the haunted house, as well as experiences that happened in the lab prior to the haunted house. The nice thing about the haunted house is that it was broken up into these different segments. So we can really look at idiosyncratic fear now. So Vinny might be really scared of nurses with syringes, but I might love nurses with syringes, but I'm terrified with clowns. So we can actually have idiosyncratic fears that's sort of individualistic to a person and themselves. And then what we can do is look at fear ratings and heart rate on a segment by segment basis. So we know it's not specifically about the content of one part of the haunted house. So this is going to be a theme. We're trying to go really idiosyncratic with all of our studies, but actually about that person's subjective experience of fear in those spaces. We did see that in the haunted house, there was higher elevated heart rate while they were in the haunted house than when they were in the lab. You might be like, you're so stupid. Of course, they're walking around a haunted house and then they're just sitting stably in the lab. But we are actually capturing some parts of the subjective experience of fear with these heart rate measures, because we see that self-reports of fear for each segment correlated with individuals' increases in heart rate in that segment. Okay, so let's get to the part that actually has to do with memory. So the first thing we wanted to look is just what does threat do to memory, right? And we had this really rich naturalistic environment, so I could just show you a plot of the data, but that sort of like ruins the three-dimensional nature of what we're trying to do. So let me start with just a quote from one of our highly aroused subjects in the blood yard. So they were like, there was a lot of blood everywhere in that room. There was someone with like a saw at one point and a guy holding a saw that wasn't a chainsaw and walking around following people with it. I think there were nurses in the hospital room of doctors, like gory nurses and doctors, right? Not your most cogent narrative of an event that you might hear. And one thing you might notice is look how much detail there is that's about the perceptual parts of it, right? Like this was gory, it's this type of saw. So we know this from emotional memory research. We know that people direct their feelings or their memories towards these perceptual details, but we now want to see if we could quantify it in this sort of real life immersive events. So on the y-axis here, I'm going to show you how much they were biasing their recall to perceptual detail. So what proportion of their recall was focused on perceptual sensory details, and see how that relates to average heart rate. We get the same effects if we look at self-reports of fear too. But what we saw is that as average heart rate went up or fear ratings idiosyncratically for each individual, the more that segment's memory had perceptual details embedded in it, right? So in some ways, this was just like the most painful, expensive replication of studies that have been around since the 1950s, but we felt good that we were replicating what's been shown in emotional memory for a while. But now what we could do that we couldn't, oh yeah, Vinny, am I going too fast? Okay, good.
So heart rate acceleration, right? Acceleration generally tracks fear, but like acceleration tracks responses to people segregate.
Yeah. So the only problem with the heart rate, which we can actually get better with in the next set of studies, is that these are these like 3-minute periods. So we know what's happening in each thing vaguely. We don't know like when the gunshot went off, right? So we can't actually lock it to specific events, specific moments to look at deceleration events. So we tried this with heart rate variability too. We didn't get a great response that was reliably predicting fear reports with variability, but I think it's because it's this like prolonged state, not like an event specific thing. Yeah.
Were you saying that the higher the heart rate, the more numerous the perceptual details, or the greater percentage of recall is on the perceptual?
Both. But both are true. More perceptual details and more of the total amount of your recall was full of perceptual details. There wasn't a relationship with how long your narratives were based off of fear, so the proportion is probably the better metric for it. Cool. Oh, yep. Oh yeah, there's this like painfully poor undergraduates painfully scored this using the autobiographical interviewing technique, which Brian Levine created, that you split things first into episodic versus semantic memories, and then within the episodic, you say whether it's time, space, events, or sensory details. Cool. Okay, so this shows us that these are perceptual details, but then what's nice is that we know what was happening in the event, so we can extend a little bit more on the types of memory that we can probe in here. So we also looked at temporal accuracy, so we can say like, what came first, the chainsaw man or the gory nurse? And then also relate this to fear ratings, whether you have worse or better temporal memory for events that were happening in there. And despite this, like I wrote a whole grant about how this would be disrupted, and the NSF funded it. And no matter what we do, we just see that there's better temporal order memory when you're in more threatening environments than less threatening environments. One important fact that's going to come up later is that, interestingly, the perceptual biases were not related to temporal order memory. So these were independent features, meaning there was like a scaffold that in some contexts they would end up with perceptual biases, but it was orthogonal to these enhancements that we saw in temporal order memory that will come up next. Okay, so that was all the like qualia of the memory, but then we were able to have them come back a week later and recall these events while they were in the scanner. And then we can now look at sort of what is happening in the moment while they are recalling these events. And remember, from my model of memory communication, we're saying that the biases that happened at encoding would like linger and then work their way up to recall. So just to revisit that again, we think prototypically there's going to be nice communication flow through the perirhinal cortex to the anterior hippocampus. But when the amygdala comes in, it might actually be inhibiting the ability to transfer this information from the perirhinal cortex to the anterior hippocampus, so you'll get less communication flow between the two of them. So that's going to be our dependent variable. So this is in real time while people are recalling their memories of these events, and we're going to look at the functional coupling between the perirhinal cortex and anterior hippocampus as a function of how many perceptual details were embedded in their recall. And we see a negative relationship between these two, which mirrors the encoding data that we found, that you actually sort of get less information processing into the hippocampus under these states of threats, leading to more perceptual details embedded in memory. But remember, we had this orthogonal feature of memory, which was temporal memory. And here we might predict the opposite, because temporal memory is about relational binding of when did you see these events in time and space. And we see a modest positive relationship between these two things. And I really emphasize modest. Like, this is not a home run of a finding, but we are seeing that there is this variability that when you're embedding more temporal order into your narratives, the more you're seeing crosstalk between the perirhinal cortex and the anterior hippocampus during recall. So in many ways, we are mirroring these encoding states are becoming recapitulated during recall. Okay, so just an interim summary. How am I on time? Okay, I think we're doing okay. Okay, so we saw that threat biases event memory towards perceptual details, which is associated with disrupted hippocampal engagement at recall, but sometimes people were able to maintain the temporal order of events in these threatening situations. So I said this whole talk was going to be on memory communication, and I have yet to say anything about memory communication. So we are now moving from recalling threatening memories to communicating threatening memories. So what we did is we took these memory narratives that happened from people from the haunted house, and we sent them to naive listeners, right? So people that did not experience the haunted house on their own at all. And then we just asked participants to rate how confusing did you find this memory, right? This now gives us a sense of like, how cogent is it when somebody else has no idea what's going on, is trying to figure out what's going on from the memory recall that participants shared. So the first thing we found is that memory for the haunted house were rated as more confusing than the lab. This is probably 1000% stimulus driven. Like, there's nothing confusing about saying I filled out consent forms, had a heart rate monitor set up, and then filled out questionnaires versus like a guy with an axe was swinging at my face, right? So this is probably stimulus driven. But what we then want to know is what was the feature space of these memories that changed whether they are more or less confusing. So in the next set of analyses, we're basically going to control and account for whether they were in the haunted house and lab. And this is now just general across all the events, what was predictive of memory confusion. And we looked at three features, perceptual memory, temporal memory, and then we wanted to look at the interaction between the two. And what we found is that people in general, when there was more perceptual details embedded in an event, they found it more confusing. When there was more temporal memory in an event, they found it more confusing. But this was all qualified by an interaction between these two features. And what we found in this interaction is that if you had temporal order memory, so you were able to sort of have some structure over the content of the event, the more perceptual details you had, the better, right? People were able to understand this because this might be a full event narrative. But when you didn't have temporal memory, you're just jamming a ton of perceptual details in there, people had no idea what was going on, right? So if you're in a purely perceptual bias-driven world, event communication was quite poor. If you're embedding perceptual biases with some sort of temporal structure, we don't think temporal structure is the only thing that does this, but temporal structure was one way to actually turn these perceptual details into a cohesive narrative. Okay, so this shows that perceptual biases in a narrator's recall can disrupt event comprehension, naive listeners, unless you're also able to engage these sort of temporal order moments that were happening too. So we were pretty excited about this. Reviewers are not, we can't get this published, but we were pretty excited about this. But then we were also thinking like, okay, this is great, but we're really coming into this like hardcore as memory researchers, right? And there is more to the world than just what you remember, especially in the world of communication. There's ways in how you express these memories to other people, right? So there's content, and then there's all the ways that you can actually vary content based off of the way you express it. So in the next study, we wanted to look a little bit more, not just on the content of memory, but also the communication style of individuals when they were conveying these memories to other people. So we turned to some natural language processing, specifically Luke is a program that uses a bunch of different data dictionaries to qualify different styles of communication that existed. And we're most interested in two styles. One is authenticity in language. So this is where it's perceived honesty with genuine, it's spontaneous speech. I like strongly identify with this space because I have impulse control issues, but you're basically just speaking freely without a lot of formal logic. Another form of communication style is these analytical thinking, right? So this is more formal, logical thinking. You see a lot of structure in the language. It's considered more impersonal and cold, whereas authenticity is considered with a lot of warmth. So we wanted to see beyond memory accuracy and temporal order and perceptual details, was the sort of qualia and the way that you're expressing the memory going to change people's perceptions of those memories? So what we did is sort of the same type of model that we did in the previous study, where we set free recall narratives to, oh wait, I skipped a slide. First, we took the memory narratives from the haunted house and we scored them on these measures of authenticity and analytical thinking, right? So we want to see, what does threat do in terms of changing the way you express what happened to you. Importantly, these are all segments of the haunted house. We excluded the lab in these analyses, and we're just splitting them up based off of whether people consider them a high threat or a low threat event. Okay, so what we found is that threat actually increases how much you use authentic language in your memory narratives, and threat also increases how much you use analytical language in your narratives. And all these are independent of the amount of perceptual details that you put in temporal order. We're like on an orthogonal path here for this section about these communication styles. So we saw these really interesting differences in linguistic style when people were under threat or not, but then we want to know, like, does this matter, right? And the student that was working on this, Stephen Martinez, who's awesome, is really dedicated to applied science. And what he really wanted to think about was stuff that you see in eyewitness testimony, right? How does this change the way you believe something is accurate or honest, right? Because these are the things that sort of matter when you're in these communication contexts. So we tested them by showing people two transcripts from different people describing the same event, right? And each one of these transcripts comes with its own analytic scores and authenticity scores. And we had people make a two alternative forced choice of which transcript did you find more accurate? So what's more accurately conceptualizing the event? We also had a whole set of questions on honesty, but honesty was not influenced by these linguistic styles. So I'm going to focus here just on these accuracy judgments. Okay, so what we can look at here is the percentage of narratives that were selected as accurate as a function of their authenticity difference scores, meaning if you see a positive relationship here, it means the more authentic was, the more accurate you found it in this two alternative forced choice. Cool, okay. So what we found is that authenticity did nothing. It wasn't related to people's perceptions of accuracy at all, but we did see this really strong positive relationship that the more you imbue your language with analytical thinking, which is really bad news for me as an academic researcher because I rarely approach things analytically. But if I did, people would believe my research more than they do now, right? So there's this really strong relationship. Ready for like the most horrifying, spooky finding, because today is Halloween of all days. None of these measures of accuracy were related to the subject's actual accuracy for the event. So we tried looking for a relationship if other people could tell how much like valid, accurate information processing was happening, and there was zero relationship between them. So this is a really terrifying thing when it comes to eyewitness testimony, is that the truth of the situation is barely relevant, and what is relevant is basically how well you can sort of convey your language to other people when you're talking about them. Hashtag, like, I really don't think we should be using eyewitness testimony for anything. Okay, so in this third study, and sort of combining it, what we know beforehand is that despite threat like actually disrupting people's ability to understand an event and what's happening. It's like having different responses on whether you think that's accurate or not, which is like a pretty, like I said, terrifying, confusing space that like, but it also explains like Breitbart and Reddit and Twitter and every social media platform in the world. I shouldn't get political, but like there's this sort of like a massive disconnect between event comprehension and what you're deeming accurate or inaccurate. Okay, so this could be the end of the talk, but I got really excited about some new work we've been doing. So I'm going to conclude on this last work, which is like fresh off the press, the first piece of data that's coming from my lab in Oregon. But I had a graduate student coming in, and we were framing all of this stuff through the lens of like recall and memory, right? Like even when we talk about trauma or other psychiatric disorders, it's like, oh, their memories are fragmented, right? But the other thing that could be happening is that it's not about memory. It's that like while in real time, I'm trying to understand an event, threat is making that more difficult, right? And what's happening is that there's actually distortions in event comprehension that are emerging as an event is unfolding. And then that contagion of confusion just transfers its way to recall and then transfers its way to communicating with others. And this is a really important question because if we're thinking about intervention space, we need to figure out where we need to intervene, right? And it might be that it's as soon as encoding that we actually need to start working on sort of modifications there rather than trying to re-edit memories. Okay, so how do we study this? So what we did is we had participants in the scanner. I'm not going to show you any of the imaging data yet because, quite frankly, we haven't analyzed it yet. So I'm going to be focusing on behavior. But we ran this study where we had people watching horror movie clips or neutral movie clips. And we made sure that we like grabbed the neutral movie clips from the same movies as the horror movie clips. So if you're a subject and there's like a movie, you would either see the horror or the neutral event, and then that was counterbalanced across all the participants. After they watched these 2-minute clips, they were asked 3 questions: rate this movie on arousal, rate this movie on valence, and rate this movie on how well you understand it, right? And now, importantly, this is not a memory comprehension question. This is an event comprehension question in real time. How well do you understand this event? Okay, so we did an online study with 168 people, and then we have the sample of 43 that's in the scanner. And what we found was for the horror movies, in both samples, they were rated as more confusing than the neutral movies. But again, you should be like, this is a really stupid data point. Maybe the horror clips are just intrinsically more confusing than the neutral clips. So what we did is we switched into multi-level modeling where we can now look at variability within one movie. So if Allie finds this movie of a clown really terrifying, but I find the same movie as a clown not as terrifying, what does that do to our own individualistic event comprehension, right? And in both of these cases, we didn't find reliable effects across the samples on arousal measures, but for valence measures in both samples, we found that the more negative you idiosyncratically found a movie clip, the less you understood that movie, right? So all these distortions and memories might be emerging immediately from a sense of event comprehension, right? But then if this is true and the whole idea of encoding contagion or confusion contagion was accurate, this confusion measure should then relate to downstream memory for these individuals, which then relate to the communication in other people. So what we did is we had people do recall on the movie clips 24 hours later. So they were shown the first scene and the last scene of each movie clip, asked to recall as much as they could. Then we scored them on a bunch of different features of the movie clip. I'm going to focus on these 2 features because they're the most relevant for memory communication, we thought. One was perceptual, which should be self-telling from everything else that I've shown you so far. This other one is event details, which we think actually has a lot more to do with temporal order out of all these different scoring schemas. And the reason why is event details is when something is actually happening in the movie, right? So these are 2 boys that end up talking about a toy that is eventually going to murder everybody. But they said the 2 boys are talking about a toy. That's an event detail because it's telling about the action sequence that's happening in the movie. But a perceptual recall would be that the toy is round and green, right? So it's sort of leaving out the flow, but is giving you more percepts about the thing itself. So we scored all of the recalls. Again, poor undergraduates. This took so much time to score all these movies on event happenings and perceptual details. Okay, so the first thing we wanted to look at then was how does a person's individual comprehension of an event influence how much they embed their recall with these two features of memory. Based off of everything from the communication study, we would assume that this would be negative here and this would be positive, right? Like the more you understand event, the more you would embed event details. The more you understand event, the less you would be like filling it with perceptual details. Home run with event details, the more you understood the event, the more you're giving these action sequences about the movies. I don't know what the opposite of a home run is. A fly ball? I don't do sports. Did that work? Any baseball fans in the room? A strikeout. Looks like I struck out on that metaphor. Okay, so we found a positive relationship between perceptual details and understanding. So the more somebody understood an event, the more they were embedding perceptual details in them. But the story's not done because these analyses didn't include valence at all, right? And remember, there can be these intersections between temporal and perceptual details that actually allow you to have perceptual details that help embed them. So in the last set of analyses, what we did is we actually then included valence into these models to look at how does valence influence the relationship between how well you understood the event and what gets embedded in your memory. When we look at event happenings, valence did nothing to those, so it's still the same relationship that I showed you before. But what I think is really cool is that when we look at perceptual details, we find an interaction with valence. And what we find is that if you're confused, then the more negative it is, the more likely you are to load that up with perceptual details, right? So this overbearingness of perceptual details that is confusing other people in the domain is actually emerging from the person being confused by a negative event. And there's something particularly interesting about negative events that might be driving this sort of overinflation of perceptual details without having the structure to understand it. Okay, so the last thing I showed you is that poor event perception results in more perceptual details, and this is particularly true or only true for threatening events as opposed to all events. So there is something qualitatively different when you're in a state of threat than a state of mundaneness. Okay, now how am I doing with time? Oh, that's when I wanted to end. Okay, so I'll just go through some take-home points, and I wanted to leave a lot of room for questions, including your own questions, because I have all these big ideas. We just don't have them yet. If in like a year, we'll have them. Okay, so take-home points is that I think in general, I showed that these encoding states can linger, resulting in confusion contagion. We have like 90% of this map done. We have a couple like holes to fill more. Right now, my grad student is sending those narratives from the horror clips to strangers so we can have them rate them on confusion so we can look at the whole train from encoding state to confusion. And I think there is something pretty interesting about the balance between perceptual and associative details in memories that can influence event communication. We're currently going after this question right now outside of the domain to threat just to try to understand like what is storytelling and how do we structure memories to have people understand them better and enjoy them more. And then we'll try to fuse some of that back into this threat literature. And then in like really broad scheme things that we're trying to do, and it was really fun talking to the PTSD crew yesterday about this, is that we're trying to understand how these features of memories relate to things like self-narrative and identity. Like all of this narrative stuff I've been talking about is how we're communicating it to others. But I think both in therapy or when you're ruminating at home alone, or both, or all of them, like we are telling narratives to ourselves. And I think that is a really interesting space that I want to talk to Pete Hitchcock about, is about this idea of narratives and rumination and how that sort of reflects identity. But this is now getting like so grandiose, I don't even know what I'm talking about anymore. But that's the eventual direction, is to figure out what I'm talking about in that space. Okay, so a couple people to really point out I mean, everybody was wonderful and helpful, but Chelsea Hillian was my colleague at Temple, who was like the emotion expert, and there was like no way we could have run the haunted house studies without her. It was like a total team effort. And then Ziwon Chen has been like pushing through all the event understanding stuff. And she's actually presenting her first year project today at Oregon. I'm going to hop on Zoom and she's going to give the same last half of the talk that I gave because I just stole all of her slides from the first year presentation for this. And yeah, then I also, NSF, federal funding's great. I wish it will stay around. But the NSF paid for all these like super wacky studies, and I'm really happy that there's funding agencies that'll pay to send people to haunted houses and watch horror movies. Okay, and I'm happy to answer any questions you all have, and thank you for listening. Oh. Yep.
Is there any like evidence for like patients with is there any evidence for patients with hippocampal lesions that if they're in like a threatening state that they're able to kind of like remember it a little bit or like show
not even a little bit, perfectly the same as controls. Okay, so first, I love this data because nobody knows about it, and I really liked it. So in the early hippocampal lesion studies, they were showing deficits across the board, but these were really clunky lesion studies. When they got better and looked at refining it to make sure that the cortical MTL was staying intact while the hippocampus lesions were there, their emotional memory was just as good as normative controls on these, like, I'm showing you a picture of a snake versus a spider. Their relational memories stunk, but their ability to recognize emotional items and the emotional memory benefit is fully intact.
Oh, cool. Thank you.
Yep.
And then my second question was so for like the patients or the participants rather, they find the scary memories more confusing. Could it also be that if you're confused by something, you find it scarier? Like, yeah.
Oh, yeah, that's interesting. So is it the threat that's leading to the confusion, or does the confusion make you more threatened, like uncertainty detection? We don't know the answer to that yet, but what we're doing now is trying to use threat of shock to get people as sort of like state dependent anxiousness. And then that way we can keep the material exactly the same, but sort of ramp up it. I think that might answer your question, like, because that way the threat manipulation is independent of what's happening. My guess is that it's the threat coming into this space, but that's just like my guess, and that's what I want it to be for my life to be more cogent. But do I have a data point on this? Okay, we have this magic clip study where we were showing people magic clips over a month-long period of COVID. Okay, this might not be relevant, but I think it is. And then we did it during COVID because there was this subjective sense that like you don't want uncertain things. Like you find uncertainty threatening when you're in a state of high anxiety versus not. And what we found there was that memory for the magic clips got worse when people had a background level of high threat. But if they're really curious about it, they can overcome it. So that data sort of lets us know that there is something about your like state level threat that's disrupting memory. We don't have event communication on that study, and God forbid COVID happens again. So we don't want to replicate that for the sake of society. But my guess is that threat's coming in first. Yep. Do I pick or? That makes me anxious. Somebody over there.
Just for recording. I was wondering if you have any fears that the participants that were recruited for the haunted house study, like if that sort of threat that most people are voluntarily exposing themselves to might differ quite a bit from like involuntary exposure to threat that's not.
Yeah.
Like,
this is why we can't get those
fun.
papers published.
Yeah.
No, I absolutely hold this fear. We had 3 subjects of our 50 drop out of the experiment. They got to the haunted house and they're like, no way, we're not doing this. I was like, no, yours is the data I want. Like that's the specific ones I want. So with the horror movie study, we were able to get this a little bit better. So in that online sample of 140 people, after they finished the whole experiment, we asked them their movie affinity rating. So like, how much do you like horror movies? How much do you like suspense movies and how much do you like dramas or something. And for that one, we found that while affinity for horror movies shaped people's valence ratings, like they basically net shifted them lower if they were horror lovers, it didn't influence the effect of valence on memory, right? So there's something about the subjective experience of it that's shifting, but the downstream consequence on memory wasn't influenced. So we had those affinity ratings for the event comprehension study for the scanner people too, but there was only like 40 subjects. I'm not like, I don't want to draw an individual differences, negative finding on 40 subjects, but it doesn't seem to be having these huge influences. But yeah, this is like a problem that if you really hated it, you wouldn't step foot in this.
I really appreciated how much you modeled individual differences. Some recent literature, specifically with the adapted autobiographical interview, has highlighted the need to control for verbal output. So, have you looked at the differences of individual verbosity in some of these different measures?
Yeah. So the we did not look for individual differences in verbosity, but the great, I guess I'm obsessed with multi-level models. Everything's being done on the subject level, which is great. So we have 12 recalls for each subject. So verbosity is controlled per person, but we haven't looked at what like overall verbosity does. I mean, the nice part is that proportion scores and counts both do the same thing across both of these studies, and the proportion scores control for verbosity. But that doesn't answer your question of just whether like what is verbosity doing. We did test it in the accuracy study, like which one do you find more accurate? Like if you just use more words, do you find it more accurate? And that there was no relationship between word count and accuracy judgments.
So thinking about some of like the real world consequences of some of the research you're doing, as it relates to like recall in eyewitness testimony or like threatening situations, um, I'm wondering if you're planning on doing any of these analyses when like there's external stressors on the recall event, because in eyewitness testimony, that's like an external pressure that also could affect the way that people
Yeah,
recall things.
that's a great question. I'm having a self transformation moment. So if you caught me in grad school, I refused to look at retrieval at all. Like I like refused. I was like an encoding only guy. And in postdoc, I like dabbled my foot in looking at retrieval. Now we're like full blown in retrieval state. So what we know from the field, like the stress literature has shown that like this might be controversial. I think the only reliable findings in the stress literature is that it disrupts memory retrieval. Um, that might be a hot take. I shouldn't have said that while I'm being recorded. But let me reframe that. A meta-analysis by Andy Yonalina says that the only reliable effects of stress on memory is these retrieval effects that definitely make it worse. We haven't manipulated retrieval effects because I think we've been trying to like narrowly isolate encoding, but I think we need to. And what we haven't done is actually manipulated people's goals during retrieval. So you're bringing up a great point about like what is the context of like a lawyer badgering you doing. But there's the other thing of like, what if I'm trying to be really manipulative and explicitly lie to you, right? Like, how does that change it? So yeah, we need to do more work in the retrieval space, but we've been mainly focusing on encoding, but it's got to be hugely relevant.
Thank you.
Thank you. So I'm thinking that if it's hard for me to communicate threatening situations, that seems like evolution has kind of struck out in that way, because that seems really important. So I'm wondering if there's maybe the point is not to communicate it as accurately as possible, which seems like kind of like what you might be measuring, but I wonder if you sent the listener back to the haunted house, if they would be able to handle those experiences better because that had been communicated to them. Maybe there's some way that it's helpful to the listener, even if it isn't really strictly accurate
Yeah.
in some way, or any other kind of like
I have
other ways to measure like the kind of value of the communication.
I have two directly contradictory answers to this. All right, the first one is like I think that episodic memory can be a luxury that happens, and if like there's a bear trying to murder you in the moment, like maybe you just don't have the processing resources to get that into the hippocampus, right? Like event communication becomes the secondary need from like an evolutionary standpoint compared to just like escape and freezing behaviors. But the other thing, which makes me believe that's sort of like not true that we're going to get with the event communication study for the horror clips, is that we've been asking understanding, right? But I think what we could also ask is like, how much imbued emotion are you giving? So like, can I, even if you don't understand what I'm saying, am I communicating how scared I was, right? And I think that fits a little bit about getting you back to the original event, is doing it. So this next study, we're going to ask them, do you understand the event? How accurate do you find the event? And then like, what's your current emotional state right now? What do you think the narrator's emotional state were? And I think this fits in with your model that maybe we don't need fine-tuned details that we need to communicate. We just need to communicate like bad or good, you know, or like disgust or
like I need help right now.
right. Like there's all these other layers to it that we're trying to like broaden now. This is the problem when you like first approach something purely through a memory perspective, and then you tell other people about it, and they're like, "You're not doing this good enough." But like this is like a really good point that we're trying to incorporate in the next round.
So what's the difference between a threat memory that is distorted and flashbulb memories, which are, you know, so detailed? Or do we not believe in flashbulb memory anymore?
Oh, it's like, you know, I'm being recorded and
Oh
you're
my
like
goodness.
baiting me. Okay, I think they're fairly similar. Okay, when you say controversial things, you're just supposed to name the citations from it. So Bill First has these like really sort of amazing data set that he collected during 9/11 about flashbulb memories. And basically, the more flashbulby they were, the more inaccurate they were for them. Yeah, right. Your subjective competence is great for it, but I think there is a lot of distortions and inaccuracy. But I think the narrative, and just going back to like legal context and things that are real, and that I think our temporal context data, temporal order data speaks to, is that we've been asking that question wrong. Like we say flashbulb memories and they're right or wrong, and that's the wrong question, right? The question would be like, what is right about it and what is wrong about it? Like distorted means like some things might be moving up and down, but other things are staying really solid. And I say this because I think this is the message that needs to get to the eyewitness testimony people, because I like almost pulled out, if I had hair to pull out, I'd pull out my hair during the Brett Kavanaugh case, that they threw out testimony because they didn't remember what was happening in the neutral mundane part of the day 2 hours earlier. And it's like, we know they won't have memory for that, but that doesn't take away from understanding the temporal order of events of a threatening sequence. So I think the flashbulb memories are like pretty in the same space of these threat memories, but just turning up the dial 10 times more than we can turn up in the lab. But I think like the same nature and scaffold of distortions are happening for them either, except they're just way more controversial than horror movie memories.
Thanks, Deepu. Great talk as always. I was wondering, it seems like memory for both perceptual and temporal context are better across, or temporal memory are better across several studies, which goes against sort of our ideas of perceptual narrowing and those perceptual features being more salient. Do you think it's the difference is the naturalistic versus experimental, or do you think, how are you sort of thinking about this?
Okay, so that's a wonderful question, Allie, and I hate you for it. No, okay. So in the temporal memory world, like the sequence of events, there's two ways to solve this problem. One way to solve a problem is like, okay, I remember seeing Allie before this talk, and then after that, she put on my cat nose, and then this happened, and then this happened, this happened, this happened. And then I'm chaining the events very strung together in time, right? So like, if I want to resolve temporal order, I have to reactivate the whole sequence of events in it. The other way you can do it is like, what feels more old? Like, does it feel more old that I saw Allie in the hallway, or does it feel more old when she touched up my nose? She's a makeup artist. No, I don't have a huge Z under this, but so we don't know which one of those two is being used to resolve the temporal order memory results. When we tested it in the haunted house, these were the most salient events of the haunted house, right? But we don't know what's happening for sort of the mundane things that were happening beforehand. Like, do you remember when I told you what my favorite food was while we were in the haunted house versus like what snacks we ate? So what we want to do is to capture sort of the stronger and the neutral events. And myself included with the rest of cognitive episodic memory researchers right now are like getting obsessed with showing people movies as like a model of real life. But like our lives are boring, right? And movies have all these embedded narratives in there. So the real challenge is like if we do it with movies, the director wants you to understand the order of events and remember them. So we're really struggling to find like what is the stimulus space to start to test, like is it just that these like spike poles of the high threatening perceptual events you get to order those because they're like this broad gisty scaffold versus like the fine-tuned details, but I don't know what the stimulus set is yet. But I will tell you this, when we do word lists, like 1930 style word lists, we actually get worse temporal order memory in those. So there is something about the like salience and like how the event unfolds that we just don't know yet. Dave Cluett needs to figure it out, not me. This isn't my job. Yeah.
Oh, thanks. The question about the stress of a courtroom made me think about the ways in which retrieval is a social event in the lab. It's more than just the individual narrating what they remember. It's also someone listening to that, and that listening obviously can affect what one recalls, right? And so is there any control? Do you have an empathic face? Because this is a threatening event. Does, for example, presenting as an empathic listener increase recall or increase the communication of emotion and feelings of threat? Does a purely analytical listener stymie the person retrieving the memory?
Yeah.
How does that play into the retrieval process?
So we, for all of our studies minus one, we really fixed retrieval because again, like we're sort of like stemming from this encoding space and moving to recall. In one study that wasn't about threat, we didn't manipulate the listener. We just manipulated the retrieval goals of the sharer. Like you're telling a friend this story or you're just recalling it for a test from there. So we don't have data to speak to this, but we do have data. Like if you jump all the way, Vanessa, you should tell me if I'm wrong on this. If you go all the way to like therapy interventions and stuff, like the best predictor of therapeutic outcomes and I think narrative exchange is just how much you like your therapist, like more than they're like, maybe, is that wrong? Yeah, it's a big factor. Maybe, but like, so it's sort of like that says something about it, right? That like who you're speaking to is going to sort of change. But I don't know if people have looked at like how well you narrate the structure of an event to somebody that you like hate or somebody that feels warm. It seems intuitive, right? But I just don't know what the structure space is. I bet this exists in like the applied forensics literature more and communication literature that I just don't know the answer to. That was a really long answer to just say like I don't know, but it's important. I wish I knew. Yeah.
Okay, I'm going to ask the last question. So, as a sensory neuroscientist, when I see you talking about perception, I think a lot about the sensory cortices, and I didn't see that in your neural sort of model. So, I'm wondering how do you, at the neural level, what do you see as being involved, and do you see sensory cortex either its role in the encoding or the retrieval side?
Yeah, I should tell you. Can we have Phil answer this? Might be a good. might be a better. Might be a better question. No, we these are oversimplified diagrams where I'm sticking to the MTL, but I think the same predictions I'd make about cortical MTL sort of works its way back down the ventral visual stream. I don't think we're getting down to like V1 things. I know Liz Phelps at one point would have argued that you're getting down to V1, but that data is a bit controversial now. But I definitely think at the like, higher order visual cortex, that's the feed forward mechanism that's driving the PRC. And like some world of me, like Kim Graham and Morgan Brenz sometimes conceptualize MTL as just the most, anterior part of the ventral visual stream. So I think it's going back pretty far, and those distortions can go back pretty far. but I don't know if that's a very satisfying answer.
We can talk about it.
Yeah. It's just like excluding for simplicity might be what I was doing, but I do know. Oh, actually, this is great. And how dare I not with Jenny Stevens in the room? Yeah, sorry, it's huge. Because, sorry, I've been focusing on encoding and retrieval all the time, but everything that's happening in between, I think, is about cross dialogue between like early sensory systems in the hippocampus. So all these distortions are probably emerging. Sometimes I should think before I answer. All these sensory distortions are emerging over time, and I think so much of that is from these like hyperconsolidation mechanisms that are happening in early sensory cortex that I think are getting orchestrated by the MTL, but are like living in sensory cortex.
Okay.
Yep.
All right. With that, let's give Deepu another round of applause. And there is a reception outside, Halloween themed reception. So we invite you to have some food, and Deepu will be out there mingling.
Yep.